So this is our final part of the review, starting at number 17. The chart above lists the number of participants by gender and age for the Boston Marathon in 2018. Use the information to find the probabilities. Write the answers as percents rounded to 2 decimal places. All right, so let's start. It says the first one is the probability the runner was 60 or over. So looking at the column, right, I can see 60 plus. It says there were 2,688 runners that were 60 plus of the 29,976. So we can look at that in Desmos. That way I can show it to you. So we have 2688 divided by 29976. Okay, so if I'm trying to give a percent to 2 decimal places, it means I need to grab 4 decimal places. So I have 0, I have 8, I have 9, and I have this 6, which I'm going to round up to a 7. So let's first write that as 0.0897. That becomes 8.97%. That way, if you have an answer that's supposed to be a decimal, you know what the decimal looks like, we know what the percent looks like. Part B says the runner was 60 plus given the runner was a male. Okay, anytime it's given, this given part, runner was a male, that becomes the denominator. So this time the denominator is 16587. And then in the top, we do that intersection of men that were 60 plus. So this is 2,048. So really important that you understand this. This is called conditional, right? So we go whatever's given goes in the bottom and then the intersection goes on top. Again, let me switch over and show you that in Desmos. So I have 2048, then divided by 16587. So that really is 1, 2, 3, 4, except that's 7, right? So I'm looking here, 1, 2, 3, 4, but the 7 tells me round that up to a 5. So at first I have 0.1235. That says 12.35%. Okay, part C says probability the runner was male. So altogether the male was 16587. Now this is back to the total of 29,976. Anytime it says given, I change the denominator. If it doesn't say given, then I go back to the original total that we had. This time I'll just tell you this comes out to 55.33% when you put in the calculator. And then part D, it says runner was male given the runner was 18 to 39. So 18 to 39, that's where I want to start. So I'm going to look up in my chart and look at 18 to 39, and I had 12,108 people in that category, and then male in that category was 5,489. So I put that in my calculator and it says 45.33%. Okay. Looks like I have 2 part Ds. Look at that. All right. The second part D says, oh, this is probably supposed to be an E. It probably changed the letters when I put it in this format. So E says the runner was 40 to 59 or a female. Okay, important that it says or. So let's erase some of the stuff that I put on here so you don't have to look at it. All right, that way we can kind of highlight what are we looking at. So 40 to 59, let's start that it's, oops, it's copying too much. So this is my 40 to 59 are all of these people. So 40 to 59 there. Or a female, so let me highlight those also. Now what I need you to see is there's some duplication. You have some choices on what to do. You could do the 15,180, right, as your 40 to 59, plus the 13,389 as the female, and then subtract the 6,130. That's one way to go. Probably a better way to go would be just to add up the individual pieces so you can see what's happening. So I have 6,619, 6,130, 640. So there's the females. And then I just need to pick up this other part, the males that were 40 to 59. This is 9,050. And this goes over the total of 29,976. Okay, so we have to get that total and then divide. That total is, let me put it in my regular calculator. So 6619 plus 6130 plus 640 plus 9,050. This is 22,439 divided by 29,976. This works out to 74.86%. Okay, so big amount. The other part, and I kind of lost it in here with the room I have, but we'll make it work. It says a runner was 40 to 59 and female. So big difference between looking at or versus and. So with the and, it means it meets both categories, so 40 to 59 and female. So this time it's only 6,130 of the 29,976 people. That comes out to be 20.45%. Kind of had to shove that in there though to make it work. All right, 18 says an investment has a 25% chance of profiting $10,000. It has a 10% chance of profiting $14,000, and it has a 65% chance of taking a $5,000 loss. What's the expected value of the investment? Right, so 25% chance of 10,000 plus 10% chance of 14,000, and then 65% chance. Make sure you put the negative to show it's a loss. So expected value is the probability of each outcome times the outcome, and then add it all up. This comes out to $650. 19 says a 25-year-old can purchase a 1-year life insurance policy for $10,000 at a cost of $100. Past history indicates the probability of a person dying at age 25 is 0.0015. Determine the company's expected gain per policy. Okay, so two things that can happen. The person can live, or the person might die, right? That's what we talked about in class 2. So if the person lives, then the company doesn't have to pay anything and they get to keep $100. If the person happens to die, then the company has to pay $10,000, but they keep the $100 cost of the policy, right, that they got paid. The probability of dying, we said, was pretty small, 0.0015, which makes the probability of living really high, 1 minus 0.0015. All right. So we're putting this into our calculator to see what happens. I'll show you some steps. So 1 minus 0.0015, this is 0.9985, and this will be times 100. And then if I have the negative 10,000 plus 100, this is negative 9,900 times the 0.0015. So the first part, 99.85. The second part, negative 14.85, says they expect to make $85 per policy. All right, last one, number 20. A bag has 4 red, 6 green, 1 gold, and 2 purple marbles. You select 2 marbles at random, and then you want to find the probability of picking 2 green marbles. All right, so how do I start? Well, like always, I need to know the total. So I had 4, I had 6, I have 1, and I have 2. That's a total of 13. The first time we pick a marble, we look, there were 6 green out of the 13. The assumption is we got a green the first time. That's the only way we can get 2 greens is if the first one's green, which means there'd be 5 left of the 12 marbles left. So once you're picking a marble, you're not putting it back in. You could multiply this through, you could do some canceling. Let's just use Desmos again. I think that's probably the best choice. So here I'm going to say 6 divided by 13, and then I'm going to click over so I can say times, and then I'm saying 5 divided by 12, I think that's a good way to show you the multiplication, and then I can hit the fraction and it says 5 over 26, so let's go back and do that. But if you like to go like the long way and say, let's get rid of 6, goes into 12 twice, I have 5 on top and I have 26 on bottom, that works too. All right. B says the second is red if the first is purple. Well, here's what we know. If the first is purple, it means that there are not 13 left, there are now 12 left, and I know that we haven't used any red. There are 4 red still. So 4 of the 12, it says 1, 2, 3. The second is gold if the first is red. Okay, the first is red, so I know there's 12 left because I already have the red one. And then the second one is gold. Well, there was only 1 gold anyway, so that's 1 over 12. This says, the last one, getting 2 green or 2 red. Well, notice we know 2 green. That's what we did in the first thing. It was 5 over 26. We don't need to do that again. But then 2 red, well, we have to look at drawing twice and getting red. First time there 13, second time there's 12. So there were 13 marbles to start and 4 of them were red. Once that was select 1 red, there's only 1 red remaining. We can cancel if you want the 4 into 12, right, and make that a 3. Or you can leave it and say, let's just go over, and we can make the whole thing happen over in Desmos. So in Desmos, I'm going to say 5 divided by 26, and then let's say plus 4 divided by 13 times 3 divided by 12. Okay, again, click it back over. It says 7 over 26. That's what we want to write.